As I was saying before my phone so rudely cut off, glad I check once in a while, didn't get too far. It's good to have a shorter video. Eat sandwich. If that's east, whatever is east in my sky, eat sandwich stuff. That's still east when I turn around, but instead of being on my left, east will now be on my right. When I draw it on the picture, that's here. East. This confuses people, understandably. Just go over it until it clicks, like, oh yeah, okay. I know what you're talking about now. Eat sandwich, drink wine. Say it's good for you, just always in small doses, right? Eat sandwich, drink wine. Great. The other thing that confuses people is that, as I said, sun, moon, stars, planets, rise, sky stuff, rises somewhere in the east. Right? So I'm going to go here. If it rises over there and I turn around, it's rising on my left. Now it's rising on my right. Still rising over there. I didn't change, right? But now if I go to draw that, rising here. And then of course that means that it's setting, so it's flipped. So just pay attention. This is a lot of this class. We're paying attention to details that we never paid attention to because, notice the arrow goes up, the arrow goes down. Just like we did in chapter 1, watching sun rise and set. All right, cool. So those are our cardinal points drawn on our flat picture, our fancy picture here. Well, we can draw it over here. I started to north. But there's a lot going on, horizon. And really north horizon, again, keep in mind that's eye level. But let's just draw it here. It doesn't matter which way we face. I really don't care. I'm going to face north, whatever. I should face south. Let's face south. Who cares? I'm going to put north there. Fine. Oh, but I put north over there. Whatever. Okay, there's north. That means south is behind me or in front of me, whichever way. The opposite direction, south. If north is that way, then wine. Say it. Wine it. Quit my whining. There it is. Now if I face north, I got wine. Those are my, what are they called? Cardinal points. I turn around and face south, and I got eat sandwich. Okay, those are my cardinal points. Where's the other one? Oh, the meridian. What's the meridian? Oh yeah, that connects, that divides the sky into an east and west half. I'm gonna flip that now. I'm gonna go down here and show you where it would be here in our fancy sort of 2D, 3D picture. So you see, it would be like this. We look up and it almost looks as though we're surrounded by a big dome. Some people even actually, they don't think about it and they pause and go, hey, they start thinking about it. Are we inside something? Are we inside a big dome? And if your friend says that, don't call them dumb, because great minds of the past, great thinkers thought that was true. It kind of looks that way, right? Like all that stuff is moving around on this big dome, and we'll talk about that. That's what it kind of looks. Anyway, so where would the meridian be? Well, here, of course, would be the horizon, eye level, coming around. And what this would be, that direction would be the zenith. And where then again is the meridian? You know this, you've known this most of your life. It would be an arc that connects north up to the zenith and down to south. Up and over, north to south, and it doesn't matter, south to north, up and over in this planetarium dome, north to south, south to north, straight up and over. And notice what it does. It divides the sky into a west sky and an east sky. So let's write what that is. The meridian, like middle, right? Meridian. Now how do I draw that on here? So that may make more sense, but it's kind of hard to draw. Over here, I draw it. Let me make sure you're still with me. You're seeing this. All right, we're good. I just want to divide the sky into east and west half. So I draw it straight up. This is going to be cool. Okay, that is the meridian. It is not the zenith. Zenith is straight up. Meridian is that line from the horizon to zenith, back to horizon. North, south, south, north. Okay, so that's the meridian. And I could draw it here too as the meridian. And scribble it, because you can do it better than that. Turns out I'm going to want to use that picture. I'll show you why. So there's the meridian. West half, east half. East half, west half. Divides the sky. So that's a useful thing to do, to divide things up when you're talking about where things are. You know, some things in California, some things in Nevada, some things in New York, whatever. Okay. We watched the sun quite a lot. And when we did, we saw it rise up. And we saw that day by day it changes a little bit, and month to month where it rises changes quite a bit, and where it sets changes quite a bit, and how high it goes changes quite a bit month to month. Hence the seasons. But you know it's going to rise somewhere over here. So we're going to go sun. Take a look at sun. And as sun goes up, around noon, right? Now, this is important. Let me just say this. It's not going to be exactly noon. Because if you think of a time zone, any time zone that you're in, there's a width to the time zone. So everybody in that time zone has the same thing on their clock, right? They're saying the same thing, but they're actually at a slightly different location. And so where sun would be a different location too. And let alone the daylight saving time, that's just a choice. But where you are, so it's not exact, but you know, about. Sun's going to be highest around noon. Okay, so I'm loosely saying it. And then, of course, you know, over here, well, sun sets, right? So sun sets. So if I watch sun, now check this out. Come back down there. Where's sun in the morning? Sun in morning. Notice that it's going this way. So it's going to cross the meridian, but it's before it crosses the meridian, right? It's before noon. And in Latin or Spanish, antes, before, antes, meridian, A-M. I wonder if you can see that. I'm going way up. Yes, you can. So this is when sun is before the meridian A.M. It's coming around. Actually from the nadir, coming around. Antes meridian. Now that can be confusing because I don't want to say it, but you could think A.M. after meridian. Don't. So where is it after noon? Don't think after meridian. Remember, antes, that's important. Antes meridian. And then after that, it's, let's draw it in a dark color, past the meridian. PM. So you're saying, when you say AM, you're saying where sun is. It's antes, or before, the meridian. When you say it's PM, it's past the meridian. And again, that goes even for when it's not a rise, so then we use that nadir, and it's like here to the nadir in the back. Okay, so that's what AM and PM mean. You can ask your friends, they don't know. Go to AM, PM market at, gas station and say, hey, do you know what AM, PM means? Now, sun can rise anywhere, on the east, right? But it's still going to arc over in the south somewhere. Rising somewhere around east, arcing over AM, antes meridian, crossing the meridian, and setting, and then going past the meridian, antes meridian, which means before the meridian, and past PM, AM, PM. That's what it's all about. So the meridian is nice. It divides the sky. We can talk about where something is relative to the meridian. And then, we're still rolling, we can finish this off and answer those two questions over there in the box. And that's all there is to it. So you get used to it, it's no biggie. But, what about azimuth and altitude? So these azimuths, these are all around. Horizon is all the way around. Cardinal points is 90 degrees, right? Azimuth is, well, I could turn, if this is north, I could turn around any amount, any angle, right? There it is. I could turn around any angle from north. We did a little bit of that. So if I do that, the angle around the horizon, and you have to choose which direction. You could have chose south, you could have chose east, it doesn't matter. But we choose north to start with, so that we know what we're talking about. And so the azimuth, or az, starts at north. So the azimuth of north, let me make that a little darker, so we can correspond with these colors. The azimuth of north is set to be 0. So if you say the azimuth of 0 degrees, that's another way of saying north. People won't know what you're talking about. And then as I turn, now you can turn towards west, right? Remember wine, west would be that way. But we choose to turn from north, go around to east. It doesn't matter, we choose to go east, okay? So we turn towards east, and I made that orange, so what the heck. And what would the azimuth then be? What would the angle from north be if I go east? Yeah, 90 degrees. And then what? If I kept going, where would I hit? Where would I hit if I kept going? Yeah, I would go to south. So how much from north around the horizon to south? 180 degrees, halfway around. That's what we needed that. So I keep going, north, east, south, west, back to north. West was black. West, azimuth of west. I start here, 90, 180 plus 90 is 270. And then I go back to north, spinning around the horizon. Now you can say, oh, it's 100 degrees azimuth. And I go, oh, that's between east and south, isn't it? 37 degrees azimuth. Oh, that's between north and east. 300 degrees. Well, that's past west, going back to north. So between west and north, 300 degrees. 303 degrees. You want to be specific. Okay. So that's all. It's a specific amount around. Okay. Let me show you that on this picture over here. And then, because I know it, I don't know, it's just a new word, azimuth. So if I look here, it's hard on my simple picture. it's hard to draw that, you know, I mean, face north and you go around, it's hard. So this is kind of nice, right? And so if I tell you a particular azimuth, I'm telling you how far around you're spinning for your azimuth. How far around? You just go around. Okay, that's all. And then you go, do you see it? You go, no. Well, you're supposed to look up. You can't just spin and look in the horizon. I'm talking about Jupiter or something. What's the azimuth? Well, the azimuth is how far around, but you got to tell me how far to look up. And that, of course, is the altitude. The angle measured up from the horizon. So how far do I look up? I spun around. Now how far do I look up? Now if I could use this, it's gonna be cool. It's gonna be cool. Let's see, 10 degrees, remember? How far do I look up? That's the angle up from the horizon is the altitude. Altitude is a little more familiar word. So the angle from the horizon of the horizon is 0. There's no wedge there, right? No pizza there. So the altitude of the horizon is what I call 0. And that's why I don't want to measure it from the ground. I want to measure it from eye level. And so put that as 0 degrees. That's my reference. And then I want to know how much to look up. The farthest you can look up is straight, because then you start going back down, kind of like that meridian. Okay, so the zenith, how far up is the zenith? I'll show you 2 ways to do this. One, of course, is from eye level, zenith is straight up. Yeah, I know you know this, but that's as far, that's the most altitude you can have is 90 degrees. So we think of altitude sometimes as height, but now we're focusing on angles in astronomy. 90 degrees up. Okay, and so if you give me a particular angle, 65 degrees, 42 degrees, whatever, then I can go out here with my cool protractor and look up. There's a guy, hey, change the game by doing this very carefully. Okay, so if I go over here and I show you this, and then I'll pull it together with a couple of cool little pieces of dessert, and we're good. So when you tell me the azimuth, you tell me how much to spin around. When you tell me the altitude, you tell me how much from the horizon, really. So from eye level, how much up. This is 0 degrees. And this is my altitude. An angle between 0, and as you know, zenith altitude is 90 degrees. 2 quick, cool things. That's all. That's all. Yeah, it's just new words. Just repeat them, whatever. You've got it. I think the one thing I'll do right now, since we're here, is you should try this. What's the angle, the wedge from one side of my fist to the other? No matter how I look on one side, close maybe one eye and look, whatever's past that, and I got a pencil sharpener right there, and then I got a fan right there. Okay, that angle between those 2 things is 10 degrees, right? Now I need to do this. That's not eye level. It's hard because sometimes you think that's eye level, that's not eye level. I need this to be eye level at the horizon. So I'm gonna measure it from there. That angle's 10 degrees. This is hard. 1, that's 10 degrees. 20, 30, 40, 50, try to keep it there, 60, 70, that's still not straight up. 80 is not straight up. 90. It works. I couldn't do it here, right? It's got to be arm's length. So that's kind of cool. You could literally measure it. You can measure thumbs if you want to take more time. So that's one thing. Here's another thing. Oh, let's go over here. A telescope. A common telescope mount changes the altitude and the amount around, the azimuth. Look, I'm changing my azimuth and my altitude. Hey, nice mount you got there. Now this is a different kind of Smithsonian, but you also have one over here. It's a pretty common one, and they've gotten actually better. So what am I changing? Horizon, altitude, more and more altitude until, didn't quite make it, almost to zenith, 90 degrees. Altitude, changing the altitude. How do I, but what if it's over there? Well, I gotta change my azimuth. And we call this an alt-az mount. You could call it an up and around mount. Up and down and around mount. Anyway, but now you know what an alt-az mount, that's, it sounds fancier than it is, cool. And then we can finally finish this off, mapping your sky. It's in review, it's really not too much, and that is this. So if I want to know, or our ancient shepherd friend here wants to know where to look in the sky, then she's got to look. She's got to spin around and look up. Now, any particular place in your sky, any particular specific direction, I could say a location if you want, a location in your sky, or an address. Give me an address for something. The trouble is, as you know, watching sun, watching patterns, stars, we've done this, things move. So if I just stand there for an hour at night, what's there is going to move. Moon's going to move, sun's going to move. Well, sun's not out at night, but stars going to move. You can do it during the day with sun. It's going to move. But I still have, if I have a particular, if I want to point in a particular direction, really, I spin around as, and I go up, alt. So a particular direction in your sky, I don't mean the celestial sphere, which we're going to get to, is given by what? The as, that's the amount around in green, and the amount up, alt. Telescopes are often called alt-az mounts, although you have other ones, equatorial, spinning around Polaris. But okay, that's it. That's mapping your sky. Now, to prep you for the next thing, what you see depends on where you are on Earth. Now, she's going to spin around. Right now, she can't see anything below her ground, right? She comes around, oh, now I can see that. But there are certain things that never get above her ground, right? It kind of creates a cone there that she can never see. Right? There's certain things we can't see. Large Magellanic Clouds, small Magellanic Cloud, right? Those close little galaxies we can't see in the northern hemisphere. Here, you could only see everything that way. You could never see anything below. Here, you could only see those stars. And so when people traveled to the southern hemisphere, they saw different stars. Right? And so where they are affects it. And then it starts getting rather confusing. And that's okay. If you understand this, then the end product will be you'll be confused. You're already confused, you just didn't know it. You'll just be aware of a lot of things, and that'll lead you to the next questions. Like, well, what about this? And some of that we won't be able to sort out in 4 months. If you just play with it, like an instrument, then, or a sport, you'll get better at it. You really can. but it just seems confusing at first. So what you see, when you see it, depends on where you are on Earth. Let's go ahead and map this Earth, North Pole, South Pole, equator, latitude and longitude. So we'll do that, take care of that business, and get out to the sky.